Hi, this is a tutorial for the D programming language. In the previous tutorial we looked at how to build D applications, and we created a simple Hello World web application using vibe.d. We didn't go into much details about the D language itself, and in this tutorial we'll create a simple number guessing game, and I'll try to be a bit more specific on the D language features we'll be using. So we start by creating an application, and I'll start by creating a makefile to easy launch the application. So this is just for my setup. And we will test the application and see that it works. So the first thing you notice is that the module starts with import statements, and this will import symbols from modules into the current scope. So this is the Phobos library, that is the standard D library. And you'll see that it contains quite a lot of modules already. And the rules of the game we'll be making now is quite simple. We'll generate a random number, and then we'll ask the user to guess this number. So the first thing we'll do is generate the random number. For this we'll need the random module. This module has a function called uniform that will create a random value. This exclamation point here says that the arguments that follows are template arguments, and the uniform call is using a simple domain-specific language for choosing how to pick numbers out of the interval, or how the interval is interpreted. So this is closing start and closing end. It's basic mathematical notation. This is open start and closing end, and we'll use closing on both sides. So it might pick 1, it might pick 10, or anything in between. The answer from, or the return value from uniform is an integer, but you might have seen other languages where you have some very verbose type variable. Stuff like this, and this is not necessary in D. You can write auto, and the D compiler will automatically understand what type you meant based on the expression on the right hand side. Another feature of D is that it contains constants and immutable values. So if we were to say a const int, this means that we won't change the answer. Someone else might be changing it, but we promise not to change it. And this is transitive. So if you put const on a class variable, then anything accessible through that reference also will be const. So it's not logical const where you just state that this is a constant, please, I promise not to change it, but the compiler will enforce this behavior. Like auto, const also infers the arguments, so you can just write const answer and it will understand that it's an integer. And D also has the immutable type qualifier, and it works like auto and const in that it might infer the arguments, infer the type, but this is a lot more strict than const. So if you have an immutable variable, it might not change at all, so no one might change it. So if you have an immutable variable, every instance must be immutable or const. You might never have an mutable reference. So for our answer variable, immutable makes sense because we generate it at the start and we'll never change it, and neither will anyone else. We don't want to change this by a mistake anywhere. Next, we can create a loop and ask the user to guess a variable. So we'll create an infinite loop up here, while true. Some people prefer this syntax for an infinite loop, so it doesn't change the semantics at all. And we'll write just guess. And the next thing we'll do is read the user inputs. This might also be immutable. We're not changing the guess after it's done. And you see it's within the while scope here. So we'll read a line from standard input, and then we'll strip away all leading and trailing spaces. This is to avoid exceptions when trying to convert it to a number later. And the readline call also will include the actual return, so we might get this result back with a new line on the end, so we want to remove that. And next we'll convert it to an integer. We'll also have to include the string library for the strip call and the conv library for converting types, or converting values. And the conv library includes this to function. This syntax here, the dot syntax, is a very convenient thing in D called unified function call syntax. So if you have three functions that you wish to call with the result of one being passed in as an argument to the other, you might have the function f called first and the return value passed into g, and the return value passed into h. So you have to read this inside out. In D, you might write this as f.g.h. And when you use this dot notation and the right hand side is a function or method, then the left hand side will be passed as an argument into the right hand side. So this will first call f and then place the return value as the first argument into g, and the same here, g will be run and the return value will be passed as the first argument into h. So C# has the similar thing, extension methods, but in D you get this implicitly. Every function might be called like this, and the parameters will, the return value of the left hand side will just be passed into the right hand side. So that's what we'll do here. So we'll first read the user input, then strip the input, and then convert it to an integer. Next, if it's the correct guess, we will write and just return. And if not, we'll just go back to the top, guess a number, read it, and check again. So this is pretty tedious to test. So while testing, we might want to actually print the answer. And this is fine while debugging, but we don't want to ship our application with this behavior. So in D you can write debug blocks, and this will only be compiled in if you are compiling the application with the debug argument, So dub automatically or by standard will build with the debug. So, but when compiling a release version, this will be compiled out. So we can say if it's not the right answer, try again. And it's difficult for the user to know, guess what number, in what range. So we'll write a little instruction at the top. So guess a number between 1 and 10. So this will give the user some hints what to do. But you see here that we have some code duplication. We have this one, and we change one, and we forget to change the others. So we'll create variables to hold these values instead. And D includes enum, and this is a compile time constant. So it's much like a define in C, but it's required to have valid types, and it's not a preprocessor or something. But the thing to remember is that every occurrence by min will be replaced with the value 1. So the min symbol, max symbol won't be visible in the compiled binary. And we'll change this one to write these variables or compile time constants, and we'll add the right formatted line. So here you have, try again. And you see that we typed 54 and it's outside the range, so we should we should check this too. So we can do this first. So if the guess is less than min or greater than max, we'll say in the range and the formatted line. So we get this, and we'll see that if we try to type anything other than a number, we'll get an exception. So we're trying to convert something else to a number, and this cannot be done. So we'll need to check our answers and see if they can be converted, and we'll do this with a try-catch block. So this is similar as in many programming languages. And the try and catch will create a scope of its own, so we can move the guess variable outside the try-catch block and only try-catch this line, or we can just put everything in a block. So we'll just put everything in the block here. And if it fails, we'll just say that it's not a number. So guess is not a number. And this should be enough for first tutorial introduction to the language itself. I'll be putting the source code up on Bitbucket, so you can download it and play with it yourself. One thing we're missing here is actually having a way to fail. So we should actually be giving the amount of tries, and if you miss on the first 3 tries or something, you fail the program. So I can leave this up to as an exercise to the viewer. Okay, that's all.